I'm going to next introduce Chris Jackson, who is the owner of Terrafilum Engineered Filaments. And he actually makes some of those great materials like the one that Ben was talking about in that last presentation, PLA TPU blend and others. So Chris, may I hand it over to you?
Sure, you can see my screen, I hope, or at least me.
I see you right now, not your screen yet.
There, you should be able to see my screen.
Now we got it.
All right, we are good then. So hello everybody. I'm going to put this in slideshow presentation. I hope. There we go. So as Jeremy indicated, Terrafilum has been around for a few years now, and I think engineered filaments is kind of what we do. We love interfacing with all of the different printer platforms that will, in our discussions, allow us to do it, and that's why we like Ultimaker so well as well, because Ultimaker is such a good friend in terms of different filaments to use and that kind of thing. One of the things I wanted to share with you is kind of my background. You may recognize this this little phrase, but I've lived my life with hope. Hope to me stands for honesty, openness, positive attitude, and enthusiasm, and that's kind of how I live my life. And it started with me wanting to play golf a long time ago, and I used standard clubs, and here's me kind of at Bandon Dunes a couple of years ago out in Oregon, and you probably would wonder, how is he going to swing a club? Well, there you go. Now you know. But you can tell from that club that for me, it's kind of difficult to swing a normal club, and that's where additive manufacturing came in for me. I grew up in Iowa on a farm, much like Ben on a farm. I went to school at Iowa State, got a degree in chemical engineering a long time ago. Worked in the plastics industries for 25 plus years at GE Plastics, which is now Sabic, DuPont for a little while. Lots of exposure to different materials, whether it's esters, amides, polyether imides, and you would know those by trade names of different things that are esters, like PETG, or you would know it by maybe Ultem. Those are the things that I've kind of worked with. Along the way, I had the fortune of being able to become a master black belt with GE in terms of Six Sigma, so lots of statistics and lean programs. So it's really helped shape me in terms of an engineer, but additive manufacturing brought it all together. And by that I mean, because my passion was golf, I needed a way to be able to hold that golf club. And holding that golf club to me was very difficult. But additive manufacturing allowed me a way to get a different grip design for myself that works. And that grip design was basically had to be able to take a tapered shaft, so the hole had to be tapered, and you know, the different materials that had to be used to make sure that under my arm it wasn't necessarily rubbing the wrong way, and how long was it supposed to be, how wide was it supposed to be, what shape did it need to be. All of those things were very important, obviously, and additive manufacturing was just such a godsend to help do that. And then on top of that, we had to coat the material so that it really provides some softness. And you know, that's how Terrafilum was born. And I took that hope attitude and really brought it to what Terrafilum is, and kind of just basically embodied all of my past into this business called Terrafilum. Let's see. Come on, advance. There we go. So our values for Terrafilum were founded on being eco-friendly. And what do I mean by that? Well, we try really hard to rescue material. What do I mean by rescue? We go out and look for odd lots and overstock materials of various molders, resin suppliers, that kind of thing, where it's still good stuff, but somebody didn't want a gaylord of it, or somebody didn't want several bags of it. And we use that in our materials. We reclaim materials. So for example, we get pellets that were recycled from bottled water bottles. So those are things that we make our PETG product out of. We also repurpose spools and different filaments. So we encourage people to send us their spools, their filaments. And you guys are printing a lot. I know you got a lot of them. So you know, what am I going to do with all these? And you don't want to throw them out. Well, we don't care. We take them back. And that's kind of why it's important to us. But along with that, from a material supplier perspective, we like to do consultations, because one of the things that I noticed when I was going through my process, there wasn't a lot of people trying to help me figure out what material to use to do, you know, my golfing problem that I had. And, you know, there also wasn't a lot of materials out there that provided flexibility. You could use this spool or this spool, and or you could get, you know, some really cheap material, or you could get some really expensive material. And how did I know the difference? Well, you know, we really encourage open designs, and so we like to help with what those designs might be. And I think that's kind of our forte. We also like to work in small batches with quick turns. We do on-demand production, so we don't have a lot of material sitting in stock for a long period of time. Our material is very fresh when we get it to you, and that's what we like, because fresh material prints best. And then from a material selection perspective, we like to help with specific applications, material properties, etc. You know, I know Ben showed you a couple in the last, and we were so thrilled to be able to help with those. Material selection is really important, and in recycled materials, for example, our PETG on the top left, that's a really clear blue material, but it's a material that's made out of recycled water bottles. We have eco-friendly materials, normal PLA, tough PLA. We're so proud of our partnership with Jeremy on being able to provide a lot of this stuff to you through his channel. And you know, one of the other things that we have that we've been slowly ramping up is bioelastomers. We've gotten a lot of bioelastomer in stock that we're testing and working into some materials. But we really take a cradle to grave approach. We want ourselves to know the resin source and the filament construction and how it was done. And you know what? When you're buying material, you should try to know that too. You should try to ask some questions about, well, where's the resin coming from? How do I know it's good resin? How do I know that the material that I'm buying doesn't have a lot of fillers in it? Those are things that are good questions to ask. From a consultation perspective, you can see we do different spool designs in the top left. Those are a 3 kilogram up to a 9 kilogram spool. This wooden spool here is particularly, we send it out, we get it, after we get it filled, we return it and we refill it again. So that's kind of cool. We have extrusion that you can see in the upper right that we extrude, and we control chart and document our diameters as we're pulling through our filament. I know industry standard is plus or minus 3% of the targets, whether they're 175 or 285. We try to control that on control chart level to plus or minus 0.03 millimeters. It's not always possible for different materials, but that's our control chart process when we're looking at a Six Sigma application. So we're constantly trying to improve ourselves from a Six Sigma perspective. Like I said, on-demand production is really important for us, and getting fresh product to you guys who do all the print makers, because that's an important consideration. And down here, we like to do custom projects. So you can see that we helped on a 3D solution. The Space Consortium needed a way to test UV stabilization of different polymers. So we created some polymer plaque openings in this big box out of that PLA TPU material. And they actually launched this box up into the stratosphere 100,000 feet up, checking UV deterioration of different polymers. So it had some electronics in it, et cetera, and that box survived on the way down. So it was exposed to about minus 50 degrees, minus 60 degrees C up at 100,000 feet. It's a good product, and that's, you know, one of the things that we like to try to do, but it's a cool little custom project. I have, with Jeremy, set up some time later this coming week where we can talk a lot about different materials, materials of construction, that kind of stuff. I just really want to thank you all for listening, and this has been really good stuff. A lot of what Yanni presented was awesome because we use some of those same techniques in our shop to repair things. It's, you know, printing, 3D printing, and particularly FDM kind of printing has a really wide variety of uses in manufacturing environments. So Jeremy, I'm really happy to turn it back to you. I think this has been so far just terrific, and I look forward to more of it.
Great. Thanks so much, Chris. Great presentation. And as Chris mentioned, everyone, we are going to have a 3D printing materials roundtable coming up on Wednesday. That's this Wednesday at 11 a.m. Central Time. So I do hope you'll join us then. All of those links are available on a page which we emailed this morning, and we will send a follow-up email so you can get those sessions on your calendar. So I hope you'll join us Wednesday, 11 a.m. Central for that materials roundtable.